Ávila Physics. Today we're going to be discussing position, distance, and displacement. Position refers to the location of an object. For example, here we can see an object with 4 different positions or 4 different locations. Location A, B, C, and D. Now, in order for position to make sense, in order to be able to describe position, we need a reference point, right? Now that reference point can be placed anywhere we want. We can place the reference point here and have our Cartesian plane be here with this as the origin. This as 1, this as -1. This would be 8. So that would make the position of A 0, -1, the position of B 8, -1, the position of C 8, 1, and the position of D 0, 1. Okay, so if we place the reference points here, those would be the positions. Now, if we place the reference point here, then the positions would be different. The position of A would be -3, 0. The position of B would be 3, 0. The position of C would be 3, 2. And the position of D would be -3, 2. So the position of an object would depend on the reference point that we choose. Now, distance. Distance refers to how far an object has moved. It doesn't matter in which direction. The only thing that matters is how far the object moves. For instance, if an object moves from location A to location B, then that object covered a distance of 1, 2, 3, 4, 5, 6 units. If the object were to move from A to B to C, then that object will cover a distance of 6 units to get to B, plus another 2 units to get to C. That would make a total of 8 units. Let's say, for instance, the object moves from A to B to C to D and back to A. That means that object covered a distance of 6 units to get to B, 2 units to get to C, 6 units again to get to D, and 2 units to get back to A. That would make a total of 16 units. Doesn't matter in which direction it moves, whether you move right or left, you're still covering distance. You're still moving. So, for example, if a person walks 10 meters to the right, then turns around and walks 6 meters to the left, what is the distance covered by that person? Pause the video here, take a minute, see if you can answer this question. All right, welcome back. By now you should have found out that the distance covered by the person is 16 meters. How did we figure that out? Well, this person will move 10 meters to the right, turn around, and then move 6 meters to the left. So the total movement of this person was 10 meters, and then 6 more meters. So that would make it 10 plus 6 equals 16 meters. And since distance doesn't require direction, then it's just 16 meters. Let's look at another example. A person is running laps on a circular track with a radius of 40 meters and circumference 252 meters. If that person runs twice around the track, what is the distance covered by that person? Pause the video here and take a minute or two to solve this example. All right, welcome back. By now, you should have had time to solve this example and realize that the answer is, of course, 504 meters. How do we figure that? Well, if the person is here and runs around the circle twice, that means that it covered on the first loop, it covered 252 meters, okay? And on the second loop, it covered another 252 meters, right? So that would mean that 252 meters, and then on the other left, another 252. So this would equal 504 meters. All right, let's look at another example. Person is running laps on the same circular track, same radius, same circumference, but this time the person only runs half the track. What is the distance covered by this person? Take a couple of minutes and see if you can answer this example. All right, so you should have had enough time to realize that the answer is 126 meters. How do we come up with that answer? Well, the person only runs half the track, which means half a circumference. So that would be 252 divided by 2, which is equal to 126 meters. All right. Displacement. Displacement refers to how much an object's position has changed while also taking into consideration the direction of the movement. So displacement refers to an object's change in position. If we put this in formula form, it would look like this. The displacement or the change in position is equal to final position minus initial position. Since displacement takes into consideration the magnitude and the direction, displacement is what is known as a vector quantity. Vector quantities are quantities that take into consideration magnitude and direction. Quantities that only take magnitude into consideration but not direction are called scalar quantities. That means that distance is a scalar quantity while displacement is a vector quantity. Now, let's look at some examples here. So, if an object were to move from A to B, then what would it be? What would its displacement be? So, displacement would be change in position, which would be equal to final position, 3, minus initial position, -3. This would equal +6. So we can say that the displacement is +6 or 6 units to the right, because we moved from A to B. We moved in a rightwards direction. All right, now, if an object moves from A to B to C to D, what would its displacement be? Well, as we know, displacement would be final position, right? Final position would be 2 minus initial position, 0. So the displacement would be 2 units upwards, right? From A to D. So we could express this displacement in 2 different ways. One would be 2 units up, or we can use the angle 2 units at 90 degrees. All right, let's look at this example here. A person walks 10 meters to the right, turns around and walks 6 meters to the left. What is the displacement of that person? Pause the video here and take a couple of minutes to answer this video. All right, welcome back. So to find the displacement, we need to find our change in position, right? Now, this person walked 10 meters to the right and then turned around and walked 6 meters to the left. That means that the final position of the person would be here. The initial position of the person is here. Okay, so to find our change in position, it would be 4 minus 0, which would be equal to 4 units to the right. You ended up to the right of where you started. So our displacement would be 4 meters to the right. Let's look at this example. A person is running laps on a circular track with radius 40 meters and circumference 252 meters. If that person runs 2 times around the track, what is the displacement covered by that person? Pause the video here, take a couple of minutes, see if we can answer this one. All right, welcome back. Okay, so in this one, we would have the person here, and the person ran 1 loop, 2 loops. And the person ended up in the exact same spot that it started from. So here we would have x2 and x1 will be in the exact same position. So if I want to find the change in position, then this would be x2 minus x1. This would be 0 minus 0. This would be 0. So the displacement of this person would be 0 meters. All right, let's look at our next example. A person is running laps on a circular track. If that person only runs half the track, what is the magnitude of the displacement of that person? So here, pause the video here, take a couple of minutes and answer this example. All right, welcome back. Okay, if we take a look at this example, we would have the person here and the person runs half the track. That means that the person's final position was here. The initial position is here. The change in position is this part right here. All right. Now, this person ended 80 meters away from its starting point. How do I know that it's 80 meters? This is a circular track with radius 40, so the diameter is 80. So that means that our answer would be 80 meters. And since this person is only talking about the magnitude, not direction, so that's why we only do 80 meters. Thank you for coming. Stay tuned to my next video.